Hello everyone, my name is Amit Nainawat. I'm pre-sales engineer at Qt Company. During this session, I will talk about the cross-platform development. I will use Qt toolchain from design to deploy, which is called designer developer workflow. And we will go one more step further. I will use a MCU project and adapt it for the MPU and deploy it on a microprocessor unit. So outline of this presentation, I will give few insight on the Qt value added proposition, which is limitless scalability. I will talk quickly the difference between the normal Qt and the Qt for MCU project. Later, I will use designer developer workflow to create a fitness machine demo, which will be then deployed on the both MCU and MPU. So there are several value added proposition which Qt framework offers. One of them is scalability. I will focus on this. From microcontroller to supercomputer, Qt and our massive ecosystem provides everything you need to design, develop, deploy software for your entire product line. Create applications that are beautiful in the front end and powerful in the back end with the same code base for any hardware, any OS, and even on the bare metal. We have always been scalable in the sense of being cross platform, allowing our user to cross code less, create more, and deploy everywhere on any operating system. Our focus has been to take this to the next level and provide limitless scalability to the target and any hardware platform from microcontroller to supercomputer. We think that the collaboration is the key between the developers and also between the developers and designer. A streamlined workflow lead to a less production cost and faster time to market. Qt as a development platform unify everything you need to make your product success. Libraries and API as accessor, most easy to use sophisticated tooling also. You can now create a project on MCU, take components from the MCU project, reuse it in the high-end project and develop a high-end product. Here in this example, low-end MCU Qt application is created by designer developer workflow. Later, the same QML components are reused in a mid-range product by adding some extra features, some extra UI components. Then this QML component is again taken to create a high-end product where more function and user experience are added. This method of development across multiple platform and multiple product line has two advantage. First, which is very obvious, that code is written once and reused on different devices. This save development time. And second, your product line which look alike. It help your client to recognize your brand across different product line. That means it also creates a brand recognition. So in today's demo, we will discuss more about the limit scalability. Just few words about the Qt for device creation, which is a product deploy on the MPU side. Qt for device creation runs on a operating system which is POSIX. It requires a Cortex A kind of architecture with minimum CPU speed of 1 gigahertz. On the other hand, Qt for MCU scales down to lower device. It can run on the bare metal without a operating system, or if you need a operating system, you can use FreeRTOS. In addition, the graphical runtime is different from the Qt normal. This squeezes the memory footprint to few hundreds of kilobytes while using the Qt library with the minimum footprint. It will be several megabytes plus the operating system footprints also. So you can see it clearly here in the Qt for device creation. You will require few megabytes of memory uh, to run a Qt application. But here on the Qt for MCU, you will require less than 80 kilobytes of memory to run a Qt application on the MCU. Even though the memory footprint is heavily reduced, it does not mean that that performance would not be good. The graphical runtime uses the 2D acceleration to optimize the rendering speed. Before I start the technical demo, few words on on the demo. I'm going to show you the Qt tool chain from design to deploy. It is called designer developer workflow. Qt has developed a plugin for the Adobe Photoshop and the Sketch. Some of the other plugins are currently being developed. Uh, Adobe XD and Figma will come and this year and starting next year. And these plugins, this Qt plugin can export artwork from the Photoshop and from the Sketch. And those exported artwork can be imported inside the Qt Design Studio. And during this import process, the Design Studio creates the QML components. Later, designer can on the imported QML component, add the UX on it, validate the visual uh, directly inside the Qt Design Studio, and then code is passed to the developer. Developer uses the Qt Creator, uh, where they write C++ logic, integrate code for the graphical user interface. Qt Creator is the tool for the software development lifecycle. That is, you can design, deploy, debug, optimize, of course, develop also your application on any target hardware like desktop, embedded targets, and even on the MCU. In today's demo, uh, I will import a fitness running machine artwork from the Photoshop by using the Qt bridge. The imported artwork will be used in the Qt Design Studio to create a MCU application. QML will be auto-generated. The QML code then will be used to create a MCU project. This Qt Design Studio project can be used to add some UI and UX, but today I will use C++ dummy data to model my UI. For this, I will use Qt Creator and C++ class to provide the dummy data. This MCU project will be compiled for the desktop and different MCUs. Later, project component will be reused to create a MPU project and deploy on a high-end hardware. In my case, high-end target, I will use a IMX8. So let me open my Photoshop. So here is my Photoshop. If you know a bit about the Photoshop, the artwork are divided in the layer, which is on the left hand side, the layer view. On the right hand side, this is the Qt Bridge, the plugin developed by the Qt company. And by using the Qt Bridge, you can import your artwork to a intermediate format. From there, Qt Design Studio can create the QML automatically for you. And in the Qt Bridge, you have to set how you want to export each layer. You can export as child, component, merge, or skip. And you need to give a path to the import. I have already set that. And once you have set your path, you can just export your artwork. So when my artwork is being exported, let me show you the Qt Design Studio. So this is the Qt Design Studio, a tool for the designer and the UX engineer. Let's create a new project for the MCU. Let, uh, let's call it uh, fitness MCU, and let's put it in the today's demo. Okay, I can adjust the screen size, but yeah, this can be done later also. So this creates a just an empty project, and this project can be run directly. But before we do that, uh, let's import the artwork which we just exported. So artwork is here. So I'm looking for something called a metadata file. This metadata file is created while exporting the artwork, and this contains all the information regarding the artwork. So right now, Qt Design Studio is parsing that metadata file and creating the reusable QML component. It takes some time. It depends on the speed of the PC, but the QML files will be created. So now you can see that those QML files are being created. So, and once those QML files are created, we can close this window. If we look now, so my QMLs are now created. I can see my my artwork. It's now a QML component. I can go inside those components. So and work on directly on those components. Uh, but today, instead of working on the components in the Design Studio, I'm going to create the MCU project out of these QML auto-generated QML files. So I'm going to take this reusable QML components and create a a Qt creator project, which then will be deployed to the different hardware target. I have already started doing that, so I have created a fitness project. This is the make file. I have put the QML components in it. But before I compile these QML component, I am going to add some dummy C and C++ files. The use of these C and C++ files are creating some animation vectors. These vectors will be used inside the QML component to animate the graphical user interface. As our final goal today is to deploy the application to MCU and MPU. That's the reason I preferred the dummy data in C++ object rather than doing the uh, timeline or creation of the states in the Qt Design Studio. You may already know that the animation can already be created both for the MCU and MPU inside the Qt Design Studio. The another way to add the animations is by adding some JavaScript functions. And of course, the C++ object is also used to add those dummy data. Um, Good thing about the C++ dummy data is later you can just replace those C++ interface and plug directly with the backend interfaces. So I have this project. I have this MCU project. The first thing, so it is here. This my MCU project, and the first thing I have to do is to bring some um, C++ files in it, which will create the. Okay, I'm copying some C++ files. I'm going to show you those C++ files. And before, let me add the those C++ file inside the project. So I have copied three C++ files, and one of the C++ file is used to generate the interface between QML and C++. So QML target generate interface takes a header file as input, and it generates a C++ to QML interface. So now I can try compiling this project for STM MCU first. So for the MCU first, so I'm looking the discovery, and I can choose any of those hardware platform, the NXP1, and then the project will be passed. So all my header files and source files are added. Uh, Now if I go in here, uh, now I can use that uh, header workout timer, which is the class which I added. So let me just first explain you this class. So this class is a structure with some property, and this property will change this property will automatically change on a timer. So as soon as the timer is ticking, this property will change according to the timer. And this workout timer.h is the input to my QML target generate interface, and this function will create a interface between this .h, the workout timer.h file, and the QML. And how to use that? It's quite simple. So let's say I want to animate this image with the property X. So I'm going to copy some code here. So on the property X will be change, uh, and the workout timer dot running is used to indicate the property running true. It can be true and false. So this 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 is one way to use the the QML to C++ interface. Here is another instance of using the workout timer structure. So speed is used here. So I have adapted all my QMLs for this workout timer. So instead of using the timeline, now I'm using the workout timer as the animation data, the dummy animation data. So let me save it. My project is already ready to compile it on the ST F7 target. Okay, I have my ST board, which is here. So let me compile it. So project is being passed. Okay, it was because it was not saved, so I save it and I run it again. So my project is being compiled now. I'm going to put my ST target here. So now project is being linked. My ST target is running one of the example which is already inside the Qt creator. So once project is linked, Qt creator is going to write the application, the fitness MCU demo application is on the MCU. So now it is compiled, and the Qt creator started writing the application on the MCU. You can see that the the slide is blinking. That means application is being written. So now application is written and MCU is rebooted. So my application uh, is already working fine. So this is the X animation we have added, which was here, and application is working fine on the STMF7 target. To save time, I have cross-compiled the same application on a NXP 1170 target. It's a bit bright screen, not very easy to see. So this is the NXP uh, automotive board. It is called RT 1170. So the same application is running on this board also. Uh, so the the process to run the same application on an XP board is quite simple. You just need to recompile the Qt for MCU project. It doesn't require any change of the source code. So the the Qt for MCU projects are cross-platform in nature, and you just need to compile and deploy. So everything working fine on the 1172. Now, going further, we need to deploy this application on the MPU now. So for the MPU also, I created a small project, and this project also I need to add the C and C++ files like we did it like we did on the uh, MCU project. So this is the MPU project, and this MPU project I'm going to copy some dummy C and C++ files. Okay, okay, now files are copied, and I can add those files here. So I'm just copying it directly like this. So I add my uh, workout timer.cpp, and I add my workout timer.h here. So both files are copied, and now this project uh, we can compile it for let's try to do it for the NXP IMX 8 device. So I have my toolchain which is already configured here. So my header and sources are already there, and I need to adjust my main file. I need to include my workout.timer.h here, and from the workout timer, I'm going to create a QML library. Uh, the API is called QML register type, and once this API is created, we can uh, we can evoke the workout timer directly inside the QML component, and this how we initialize the workout timer. So this workout timer is same like the MCU, but instead of generating the QML to CPP component, well, it is creating a library out of it. It looks a bit different because if you know the Qt, the normal Qt, it has the functions like Q invocable, which enables a C++ function, and those C++ function can be called inside the QML. You can create the Q properties, and those properties of your class can be called directly inside the QML. So here in this MPU project, the QMLs are same. Just the dummy data is binded with a different kind of a structure. So once it is called, let me let me now show you uh, my IMX 8 device. So this is my IMX 8 device. It is sitting on this IP address. Uh, it is running a Linux which is coming from the Qt company itself. So I can just now compile my project and deploy it on directly on this IMX8 device. So now project is being compiled, and and now it is deployed directly on the IMX8 device. So the same MCU project is now running on the IMX8. So little bit of speed and start. So it's the same QML component, same QML code, just the dummy data is now coming from a work out timer class. And on the MPU side, well, it was coming from a structure which creates the QML interface. So my project is now deployed to the IMX8. Uh, it is already scaled, and then all those components is working as it was working on the RT 1170, NXP RT 1170. So between MCU and MPU, you can reuse your QML components. So I have finished my demonstration. So it is time for some question and answer. So I wait for your question. If you have some questions, let me know. I will be happy to answer that.